Here's how to calculate the tonnage of your chiller that's utilizing either water or 40% propylene glycol solution using the universal hydronic formula. Here's our chiller example. We have 480 GPM going through the evaporator. We have 55 degrees entering and 45 leaving. So let's use the universal hydronic formula to calculate this tonnage of water flowing through the chiller. So this is Q in BTUs per hour equals 500. We'll talk about where that comes from in a minute. So it equals 500 times 480 GPM times 10 degree delta T equals 2,400,000 BTUs per hour divided by 12,000 BTUs per ton to get the ton, and that's 200 tons. So that's what this chiller is producing with just water. Let's look at what happens when we add glycol to the system. So this is where it's important to know where this 500 comes from. So the 500 comes from multiplying the density of water times 60 minutes per hour conversion factor times a specific heat, which is this case for water is just 1 BTU over pounds degrees Fahrenheit. Now the important thing to note is the density and specific heat does change with temperature, and given these are at relatively standard conditions, this is a widely acceptable value for the density and specific heat for just water. So what happens when we add glycol to the system? So we've got this pre-charged, pre-mixed 40% propylene glycol solution, and what's going to happen is the density and the specific heat are going to change. So the new density is, on the data sheet provided by the manufacturer, which is 8.51 pounds per gallon. Now it's important to note this will change with temperature. I don't see a temperature rating on this sheet. I'm probably just missing it, but at standard, these are rated at about 60 degrees for fluid temperature. So not a big deal for this example since we're at relatively normal temperatures, but just be aware of that if you're doing this calculation. So the specific heat, again, depends on, of course, the mixture of propylene glycol and also the temperature. I'm going to use 0.88, which is the specific heat of 40% PG at about 50 degrees. You can find that with many credible sources online. The important thing to note is these do change with temperatures. Okay, if we go back to our formula, it's 450 now times 480 times 10 degree delta T, which equals 2,160,000 BTUs per hour divided by 12,000 equals 180 tons. And as we would expect, adding glycol to the system does derate the tonnage of the chiller. I want to thank the folks at Peak for providing this thermal charge solution, 40% propylene glycol, so that we can do this demo.